Well, welcome to the Grok 3 presentation. So the mission of xAI and Grok is to understand the universe. We want to understand the nature of the universe so we can figure out what's going on, where are the aliens, what's the meaning of life, how does the universe end, how did it start, all these fundamental questions. We're driven by curiosity about the nature of the universe, and that's also what causes us to be a maximally truth-seeking AI, even if that truth is sometimes at odds with what is politically correct. In order to understand the nature of the universe, you must absolutely rigorously pursue truth, or you will not understand the universe. You will be suffering from some amount of delusion or error. So that is our goal, figure out what's going on. And we're very excited to present Grok 3, which is, we think, an order of magnitude more capable than Grok 2 in a very short period of time. And that's thanks to the hard work of an incredible team. And I'm honored to work with such a great team. And of course, we'd love to have some of the smartest humans out there join our team. So with that, let's go.
Hi everyone, my name is Igor, lead engineering at xAI.
I'm JB Ba, leading research.
I'm Tony, working on the reasoning team.
All right, I'm Elon. I don't do anything. I just show up occasionally.
Yeah, so like Elon mentioned, Grok is the tool that we're working on. Grok is our AI that we're building here at xAI, and we've been working extremely hard over the last few months to improve Grok as much as we can, so we can give it to all of you, so we can give all of you access to it. We think it's going to be extremely useful to you. We think it's going to be interesting to talk to, funny, really, really funny, and we're going to explain to you how we've improved Grok over the last few months. We've made quite a jump in capabilities.
Yeah, actually, we should explain maybe also why do we call it Grok? So Grok is a word from a Heinlein novel, Stranger in a Strange Land. And it's used by a guy who was raised on Mars. And the word Grok is to sort of fully and profoundly understand something. That's what the word Grok means, fully and profoundly understand something.
And empathy is important.
True.
So, yeah, if we charted xAI's progress in the last few months, it's only been 17 months since we started kicking off our very first model. Grok 1 was almost like a toy by this point, only 314 billion parameters. And now if we plot the progress, the time on the x-axis, the performance of favorite benchmark numbers, MMLU, on the y-axis, we're literally progressing at unprecedented speed across the whole field. And then we kick off Grok 1.5 right after Grok 1, released after November 2023, and then Grok 2. So if we look at where all the performance coming from, when you have a very correct engineering team and all the best AI talent, the only one thing we need is a big intelligence comes from big cluster. So we can reconvert the entire progress of xAI, now replacing the benchmark on the y-axis to the total amount of training flops. That is, how many GPUs we can run at any given time to train our large language models, to compress the entire internet. So after Grok 2...
All human knowledge, really.
That's right.
Yeah, internet being part of it, but it's really all human knowledge, everything.
Yeah, the whole internet fits into a USB stick at this point.
It's like all the human tokens, yeah.
That's right.
Yeah.
Very soon into the real world.
Yeah.
So we had so much trouble, actually, training Grok 2 back in the days. We kicked off the model around February, and we thought we had a large amount of chips, but turned out we can barely get 8K training chips running coherently at any given time. And we had so many cooling and power issues. I think you were there in the data center.
Yeah, it was like really sort of more like 8K chips on average at 80% efficiency, more like 6,500 effective H100s training for several months, but now we're at 100K.
Yeah, that's right.
More than 100K.
That's right. So what's the next step, right? So after Grok 2, so if we want to continue to accelerate, we have to take the matter into our own hands. We have to solve all the coolings, all the power issues, and everything.
Yeah. So in April of last year, Elon decided that really the only way for xAI to succeed, for xAI to build the best AI out there, is to build our own data center. So we didn't have a lot of time, right, because we wanted to give you Grok 3 as quickly as possible. So really, we realized we have to build the data center in about 4 months. It turned out it took us 122 days to get the first 100K GPUs up and running, and that was a monumental effort to be able to do that. We believe it's the biggest fully connected H100 cluster of its kind. And we didn't just stop there. We actually decided that we need to double the size of the cluster pretty much immediately if we want to build the kind of AI that we want to build. So we then had another phase which we haven't talked about publicly yet. So this is the first time that we're talking about this, where we doubled the capacity of the data center yet again. And that one only took us 92 days. So we've been able to use all of these GPUs, use all of this compute to improve Grok in the meantime. And basically today we're going to present you the results of that, the fruits that came from that.
That's right.
So let's
so all the paths, all the roads leads to Grok 3. 10x more compute.
More than 10x, really.
Yeah, really.
Like maybe 15x.
Yep, compared to our previous generation model. And Grok 3 finished the pre-training early January. And then we start, the model is still currently training, actually. So this is a little preview of our benchmark numbers. So we evaluated Grok 3 on 3 different categories: on general mathematical reasonings, on general knowledge about STEM and science, and then also on computer science, coding. So AIME, American Invitational Math Examination, hosted once a year. And if we evaluate the model performance, we can see that the Grok 3 across the board is in a league of its own. Even its little brother, Grok 3 Mini, is reaching the frontier across all the other competitors. So you would say, well, at this point, all these benchmarks, you're just evaluating the memorization of the textbooks, memorization of the GitHub repos. How about the real-time usefulness? How about we actually use those models in our product? So what we did instead is we actually kicked off a blind test of our Grok 3 model, codenamed Chocolate. It's pretty hot.
Yeah, hot chocolate.
Been running on this platform called Chatbot Arena for 2 weeks. I think the entire X platform at some point speculated this might be the next generation of AI coming our way. So how this Chatbot Arena works is that it strips away the entire product surface, right? It's just raw comparison of the engine of those AGIs, the language models themselves, and place an interface where the user will submit one single query, and you get to show 2 responses. You don't know which model they come from, and in the end, you make the vote. So in this blind test, Grok 3, an early version of Grok 3, already reached like 1,400. No other models has reached an ELO score, head-to-head comparison to all the other models at this score. And it's not just one single category. It's 1,400 aggregated across all the categories in chatbot capabilities, instruction following, coding. So it's #1 across the board in this blind test.
And it's still climbing, so we actually have to keep updating it. So it's 1,400, above 1,400 and climbing.
Yeah, and in fact, we have a version of the model that we think is already much better than the one that we tested here.
Yeah.
We'll see, how far it gets, but that's the one that we're, working on, or talking about today.
Yeah. So actually, one thing, if you're using Grok 3, I think you may notice improvements almost every day because we're continuously improving the model. So literally, even within 24 hours, you'll see improvements.
Yep. But we believe here at xAI, getting the best pre-training model is not enough. That's not enough to build the best AI. And the best AI need to think like a human. You need to contemplate about all the possible solutions, self-critique, verify all the solutions, backtrack, and also think from the first principle. That's a very important capability. So we believe that as we take the best pre-trained model and continue training it with reinforcement learning, it will elicit the additional reasoning capabilities that allows the model to become so much better and scale not just in the training time, but actually in the test time as well. So we already found the model is extremely useful internally for our own engineering, saving hours of time, hundreds of hours of coding time. So Igor, you're the power user of our Grok 3 reasoning model. So what are some use cases?
Yeah, so like Jimmy said, we've added advanced reasoning capabilities to Grok, and we've been testing them pretty heavily over the last few weeks in order to give you a little bit of a taste of what it looks like when Grok is solving hard reasoning problems. So we prepared 2 little problems for you. One comes from physics, and one is actually a game that Grok is going to write for us. When it comes to the physics problem, what we want Grok to do is to plot a viable trajectory to do a transfer from Earth to Mars, and then at a later point in time, a transfer back from Mars to Earth. And that requires some physics that Grok will have to understand. So we're going to challenge Grok, come up with a viable trajectory, calculate it, and then plot it for us so we can see it. And this is totally unscripted, by the way.
That's the entirety of the prompt, which should be clarified, is that there's nothing more than that.
Yeah, exactly. This is the Grok interface, and we've typed in this text that you can see here, generate code for an animated 3D plot of a launch from Earth landing on Mars, and then back to Earth at the next launch window. And we've now kicked off the query, and you can see Grok is thinking. So part of Grok's advanced reasoning capabilities are these thinking traces that you can see here. You can even go inside and actually read what Grok is thinking as it's going through the problem, as it's trying to solve it.
Yeah, we should say, like, we are doing some obscuration of the thinking so that our model doesn't get totally copied instantly. So there's more to the thinking than is displayed.
Yeah, and because this is totally unscripted, there's actually a chance that Grok might make a little coding mistake, and it might not actually work. So just in case, we're going to launch 2 more instances of this. So if something goes wrong, we'll be able to switch to those and show you something that's presentable. So we're kicking off the other 2 as well. And like I said, we have a second problem as well. Actually, one of our favorite activities here at xAI is having Grok write games for us. Not just any old game, any game that you might already be familiar with, but actually creating new games on the spot and being creative about it. So one example that we found was really, really fun is create a game that's a mixture of the 2 games Tetris and Bejeweled. So
this is maybe an important thing. Like there's obviously, if you ask an AI to create a game like Tetris, there are many examples of Tetris on the internet or a game like Bejeweled, whatever. It can copy it. What's interesting here is it achieved a creative solution combining the 2 games that actually works and is a good game.
Yeah,
we're seeing the beginnings of creativity.
Yeah, fingers crossed that we can recreate that.
But hopefully it works.
Hopefully it works.
Embarrassing if it doesn't.
So actually, because this is a bit more challenging, we're going to use something special here, which we call Big Brain. That's our mode in which we use more computation, which is more reasoning for Grok, just to make sure that there's a good chance here that it might actually do it. So we're also going to fire off 3 attempts here at solving this game. At creating this game that's a mixture of Tetris and Bejeweled. Let's see what Grok comes up with.
I've played the game. It's pretty good. Wow, okay, this is something.
Yeah. So while Grok is thinking, in the background, we can now actually talk about some concrete numbers. How well is Grok doing across tons of different tasks that we've tested it on. So we'll hand it over to Tony to talk about that.
Yeah, okay, so let's see how Grok does on those interesting, challenging benchmarks. So reasoning, again, refers to those models that actually thinks for quite a long time before it tries to solve a problem. So in this case, around a month ago, the Grok 3 pre-training finished. So after that, we've worked very hard to put the reasoning capability into the current Grok 3 model. But again, this is very early days, so the model is still currently in training. So right now, what we're going to show to people is this beta version of the Grok 3 reasoning model. Alongside, we also are training a mini version of the reasoning model. So essentially, on this plot, you can see the Grok 3 reasoning beta and then Grok 3 mini reasoning. The Grok 3 mini reasoning is actually a model that we train for much longer time. And you can see that sometimes it actually performs slightly better compared to the Grok 3 reasoning. This also just means that there's a huge potential for the Grok 3 reasoning because it's trained for much less time. All right, so let's actually look at how it does on those 3 benchmarks. So Jimmy also introduced already. So essentially, we're looking at 3 different areas: mathematics, science, and coding. And for math, we're picking this high school competition math problem. For science, we actually pick those PhD level science questions. And for coding, it's also actually pretty challenging. It's competitive coding and also some lead code, which is some code interview problems that people usually get when they interview for companies. So on those benchmarks, you can see that the Grok 3 actually performed quite well across the board compared to other competitors. So it's pretty promising. These models are very smart.
Yeah. So Tony, what are those shaded bars?
Yeah, so I'm glad you asked this question. So for those models, because it can reason, it can think, you can also ask them to even think longer. You can